Absolute pleasure to be here and see you all. And what a lovely drive up to the observatory. It is absolutely fantastic. You've got a fantastic location. I've heard it. I don't know Dundee at all. Came out in the train in the rain, and I've just seen an absolute gem up here. So it's fantastic. And I haven't even looked around. So as June mentioned, my interest in meteorites started when I moved to Edinburgh. And there's a couple of faces people that you know. There's Dr. Dave Gavin and Jamie Shepherd. And Jamie Shepherd and Dave Gavin, you know, they were like, well, you're out in these deserts, you know. And I say, well, yeah, I look for stone tools and all this kind of stuff. It's amazing what you can find. Have you ever thought about looking for meteorites? And then that just set the spark going on. Space, astronomy, meteorites, life, all the kind of stuff, you know, treasure hunting and ancient stuff, and that's where it came from. So the talk is first 5 minutes going to be a bit dry, then it gets on to the good stuff. Just going to be reading a bit of theory stuff. I haven't got the ability to sort of learn parrot fashion stuff like that, and then it's going to go into my own stuff, which will be all free on and be some videos and stuff like that. So we'll go ahead. Whatever you want, yeah.
Looks like, yeah, it's good. It's great, right?
A very dry photograph.
So, very basics, but what is a meteorite? So, before entering the Earth's atmosphere, extraterrestrial fragments are known as meteoroids, and these may range in size from tiny microscopic dust grains to large bodies many meters in diameter. Meteor is a streak of light produced by a small meteoroid, typically the size of a small pebble, which due to frictional heating is completely melted and vaporized as it enters the Earth's atmosphere. Larger meteoroid fragments, which may be up to many meters in size, may produce spectacular sound and light effects like lots of you have all probably seen, which pass through the air, slowed down by the atmosphere, and obviously fireballs. The huge initial speed resulting atmospheric friction causes the outermost surface of the meteoroid to melt and become ablated in a fiery manner. Atmospheric friction also causes shock waves with resulting sonic booms and probable fragmentation of the meteoroid, which may be visually observed as a fireball breaking up and audibly heard within a vicinity of up to 30 kilometers. As the meteoroid is further slowed down by the atmosphere, it begins to cool rapidly, and its molten surface solidifies, forming a fusion crust which is typically around 1 millimeter thick. You can have a look at these afterwards and you can see fusion crust on these and all that kind of stuff. The remaining debris mass is finally slowed to its terminal velocity and falls under the influence of gravity, hits the ground, and that's it being a meteorite. It's interesting that everybody thinks they're coming really fast, but it's that terminal velocity that they end up dropping, unless they're really, really big, you know, and they're coming in and making huge craters where they're taking out the atmosphere and making a huge shockwave sort of compression of the air, which causes the explosion to make something like Arizona crater. At the end of the day, these drop out the sky just like you drop a rock from upper atmosphere. So it's very interesting there. Must be noted that the vast majority of material landing on Earth is in the form of tiny dust grains, less than 1 millimeter in size, known as cosmic dust, interplanetary dust particles, or micrometeorites. These particles, having a very large surface area to volume ratio, radiate away the frictional atmospheric heating faster than they melt, thus surviving intact to land on the Earth. And if you were scraping, you're guttering, you'd be finding micrometeorites, you know, so deal there. A little bit of history now. It's all a bit dry, this, but get over. So history mentions tales and talk of iron masses falling from the atmosphere from earliest times. For example, Pliny recounts in his Natural History that about 56 years before the Christian era, a mass of spongy iron fell from the atmosphere in Lusana. The earliest book I've got of which mentions about meteorites is Jameson's Mineralogies, is 1820. I'll just read a couple of accounts, interesting ones from this historical accounts. We've got there is preserved in the town of Elswigen in Bohemia a massive iron weighing 200 pounds, which appears to have fallen from the air in the year 1647, and it is said about the same time a ball or mass of iron fell from the air on board a ship in the open sea and killed 2 men. Maybe this is the only time that a meteorite has actually killed men, or maybe this is a very convenient way to get rid of a couple of guys he really didn't like on the boat, you know. And then there's this is another little one as well, which is we've got Averroes speaks of a mass of iron estimated to weigh up to 100 pounds, which fell in Cordova in Spain, which swords were made of. That would be quite something, you know, to have swords made of meteorites. So, absolutely. So the first meteorite fall for which written records exist is the Enchisum meteorite, which fell in Enchisum, Alsace region of France in 1492. A 127 kilogram stone was recovered after a large fireball and explosion was observed. An engraving was commissioned to document the event, and the Emperor Maximilian ordered the stone to be preserved in the village church. Meteorite is still in the village, although now resides in the town hall. There's actually a festival every year that celebrates this, and one of my meteorite buddies goes there religiously every year, you know, sorts it out. So despite many observed falls and subsequent recovery of meteorites since the Enchisum fall in 1492, it was only until the late 1700s that the science of meteoritics began to be taken seriously by scientists. Even then, due to the lack of credible witnesses of falls by persons of suitable high social rank, the scientific community simply accounted for the eyewitness reports of the fall of the subsequent recovered rocks with black fume crust as simply stones which were struck by lightning. And the meteorites were then commonly known as thunderstones. So remember that thunderstones, little ode to thunderstones at the end of this. Then we have the man who really founded this. So finally in 1794, the German physicist Ernst Chladni published a short book in which he proposed, with good reasoning, that meteorites were extraterrestrial in origin. Chladni had sowed the seed for a new way of thinking. 2 years later, in 1796, the chemical analysis of Edward Howard of World Cottage meteorite fell in Yorkshire, together with other collected meteorite fragments, showed that these samples contained nickel dissolved in iron. This characteristic was not observed in any terrestrial rocks, and so Howard concluded that an extraterrestrial origin was plausible. Edward Howard's scientific analysis was taken seriously by the European scientists, and finally, any remaining doubts held by the scientific elite of Europe were dismissed at 1 p.m. on April the 26th, 1803, when a spectacular meteorite shower of over 3,000 stones fell near the community of L'Aigle in Normandy. So in the year 1803, the science and wonder of meteorites had finally begun to be accepted. It must be mentioned that many scientists still did not believe Chladni's theory that meteorites were derived truly extraterrestrially out with the Earth-Moon system, as many believed that they were either derived in the upper atmosphere in some unimagined manner or from volcanoes on the moon. Even Jameson's mineralogy, even Jameson states here that this iron is formed by unknown manner in the upper atmosphere. And he's recounted all these things of huge masses of iron coming down from history. Quick bit about meteorite types. There are 3 main groups of meteorites. Stone meteorites are composed mainly from silicate minerals comprising chondrite and achondrite meteorites. The most primitive asteroids are made from dust particles, chondrules and metallic grains, which have been preserved from the origin of the solar system 4.6 billion years ago. Chondrite meteorites are made from fragments of these asteroids, and stone achondrite meteorites are typically fragments of asteroid crust, where melting has completely removed their chondral structure. Iron meteorites, composed of iron metal alloyed with nickel, these are from the core of the magmatic or differentiated asteroids. Differentiation occurred within a few million years after the origin of the solar system, with the internal structure of these asteroids becoming internally melted and their constituents separating into metallic core, a silicate mantle and a crust. Stony iron meteorites, composed from a mixture of iron, nickel, metal and silicate minerals, these so-called palisite meteorites, are from the core mantle boundary of a differentiated asteroid. That's enough of the history and what a meteorite is. Now we get into some good stuff about identifying the meteorite. So this is one meteorite here. This is Z50 from my collection. So we can see, looking at it, shape. Blocky nature may have thumb-like imprint hollows. You can see these these hollows on there. Give you an idea, this is not one I have here, but this is about this size, this meteorite. And so it's quite big. Colour and fusion crust, the darkness of the colour. All my meteorites which I've got here, which I've collected, still have the terrestrial nature of sand, of things that of soil and debris which are connected to them. I haven't even cleaned them. So that's what this yellowy stuff is still on them, because that's worth analysing to see how they weather and how they change. You can see evidence of severe shocking. You see those lines across it. That's in the when 4.6 billion years around, massive impacts, shock lines form, and also the massive shock of them coming through the atmosphere. It's often these shock lines which cause a big fireball to explode during the weak points. But a lot of the meteorites you can see have these shock lines on. These ones don't, because they're mainly brought for their specific orientations. But a lot of them have the shock lines there. Traction to a magnet. Most meteorites, apart from very rare achondrites, have iron content, native iron in there. So your magnet is a very good test. If you think it's metallic, it doesn't have a magnet, then it's not looking good. And then weight, generally heavier than other rocks. So these ones here which you're seeing, and these ones here, are mainly from the chondrite group. Some of them have, when you look closely, you can actually see in the center here, unfortunately it's not too clear, but you can actually see chondrules in there. So that's another visible chondrule structure when it's been broken. And then if you look with a hand lens, I have some, I'll take them out afterwards. I've got some of my little meteorite tools and stuff which I have. I'll show them afterwards. We won't waste time now to do it. But you can look under hand lens. I have a diamond file, scrape down, and you can see if there's any metallic flakes and stuff like that. The next thing is orientation, and the sort of looking at this rock. Could this rock be formed on this planet? That's a big thing, because often these rocks, some of them, they just come down, blocky objects, but sometimes they just stabilize and just glide down. This is M65, which I will talk about earlier, and it's got a characteristic, amazing shape to it. It's actually this one here. You can have a close-up look afterwards. A lip of ablation on there and all kinds of stuff. So that can give away. You can't physically have a rock like that that's been formed on this planet in any terrestrial manner, unless it's man-made. Secondary fusion crust. You have a main fusion crust. Might be able to. Oh, you can't really see. But you have a main fusion crust, dark. A piece breaks off halfway up the atmosphere. There's a bit of burning, and you get a secondary fusion crust. So you get a lighter fusion crust that's not as deep. Then we've got definitive lab testing as nickel, presence of nickel. You've got that the classic, as was explained in the early test for understanding about meteorites, is iron nickel combination. And so if nickel's in there, it's a very good chance it's meteorite. Iron and nickel don't tend to form together in a terrestrial manner, and there's little simple tests you can do for that. And then you've got weathering. You've got rocks which are crumbling, decaying, don't like water, and even smell. Meteorites I found come back, you bring them out of a very dry environment, and you notice a smell from them. It's little compounds breaking down if they're not kept in a dry sort of way. So
What sort of smell, please?
it can be a sort of pungent smell. It can be like a sort of metallic, sort of pungent sort of smell of a sort of acidy kind of smell, and it's little chemicals which are just reacting with water and then being released. And
Sulfurous.
it can be sulfurous. Sort of it can be sulfurous. Yeah. And the most important thing is if you've come across a rock and there's another 10 of them in the same field and the rest of it, chances are it's just a volcanic rock or something like that. It's got to be different to the sort of general rocks around, unless you're very lucky and there's been a massive fall during the night and no one's noticed. So going back to the orientation, so we got the fastest plane in the world, SR-71 Blackbird there, and you got M65. This would have come in faster than that plane. But if you were to, you can have a look at this closer, it's got pretty much the same orientation at the front. It's got the bladed lip, it's got lines of flow, and this kind of thing was used to design the re-entry capsules and all the kind of stuff, and these planes, because it's just coming so fast. Nature has shaped it in a most aerodynamic form. Some meteorons look like meteorites. That's actually from a photo from Dunrobin Museum. That's examples of slag there. So going down, slag is a big meteoron that you find in the UK. Yeah, there's so many Iron Age things. I mean, I'm not joking. You look at, I pick up lots of iron, and my girlfriend, who's she's an archaeologist. She says, "Oh yeah, that's part from when they did the iron smelting in the Iron Age, and it's not meteorite, but she knows exactly what it is." Old, and then you've got old rusty, exploded pieces of ordnance is another classic thing. There's been a lot of wars going on around here, and you know what it's like. To be honest, you can go around a metal detector, even a spanner that's been in the field in Scotland for 50 years. It doesn't look like a spanner. Do you know what I mean? You might be able to see it, but it's amazing what tricks can be played. You've then got sedimentary ironstone nodules. They're a classic thing as well. Magnet will take those out. They don't attract a magnet. And then you've got, the problem is in Scotland, terrestrial, volcanic and igneous rocks. We've got a lot of them up here. So the good, bad and the ugly places. That looks a pretty good place there for searching, I would say. So we're looking for a good place. Typically, ideally dry place. Ancient non-igneous geology, minimal vegetation, minimal human, animal habited areas, and a visible coloured bedrock. You can get meteorites, very rare, that come down. They actually have a very light coloured fusion crust, but they're incredibly rare. The reason why they're incredibly rare is because people don't find them. So, the bad and ugly. Now you look at those two regions there. I've looked in meteorites in both those regions. One of them is bad and one of them is really ugly. So just have a think about it as I flip through. Bad and ugly continued. So that's it's actually a meteoron I found there on the left. And now this is looking in a pretty ugly place. If you look at the slide to your right, you see this little sign there. If you were to zoom in that a little bit closer, the next sign will show you what that is. Minefield. That's a pretty ugly place. That was actually in Iran, on the Iran-Iraq border, and so that's you then go a bit further. That's the remains of an F4 Phantom that's just crashed. Typically American plane, sold to the Iranians, attacked Iraq, came back and then crashed. How times have changed, and so you've got to be careful where you go in these places. It's can be really quite bad. And then you've got other hazards. June, we talked about snakes.
Yeah.
This is in Australia, and I was looking for gold, and of course eye out for meteorites out there with a metal detector with an ex-girlfriend, and she raced ahead with this metal detector, and she walked right over this stick.
That's why she's an ex-girlfriend.
This was this long. I'm not joking. And I just got, and she just walked, and I said, "Did you just see what you?" And she said, "What you?" I said, "She said, yeah, it's just a stick." I bashed my foot, and then this big, basically king brown or copperhead snake in the gold prospecting areas of southeastern Australia raced away. But one bite from that, and it's lethal.
Everything in Australia is lethal.
And that's after in Australia, you talk to them, "Oh, you don't need snake chaps." I'm saying, no one sees snakes. And then the next day, that was it. So, this is my kind of area for looking for meteorites. A little bit off the beaten track, but it's there. So So we go along. So
And where is that?
that is in a place that ends in man and starts in O, in the Middle East. And so I was working out there, and that's is in the Middle East, in the Arabian Peninsula, and so that's really it. So now we'll just talk about how this happened. I was working out there. Dr. Dave Gavin, Jamie Shep. Well, you know, you've got to manage to get out there and take some time and go looking. And I hired a 4x4 for, got the basic food together. I wasn't very experienced in that, so I had loads of water, but really poor rations and all the kind of stuff. Didn't have the kit. And just headed out into the desert for about 3 weeks. And just driving everywhere. Had quite a few experiences. It was good. But this is the kind of thing you come across, you know. Now, you think, you know, we looked at that really good area. You think, you know, you got a really nice, clean, crisp, stable geological area, nice limited vegetation. And then you see things like this. So on the left, those are rocks which have been coated in a black algae kind of crust, you know, and so they're limestone rocks that have got black on them, so they're around. This one here, you know, you see from about 400 yards away, and you think, yeah, that's going to be it, you know. That's actually part of a plastic water bottle that's been left out in the sun, and that's what it goes. You can see the ridges on it, you know. So this is the kind of thing, you know. It's not as easy as you think, you know, and. But then we get to the stage where it gets interesting, you know, and so I'll play the first video. Hopefully it's good. Got a black object ahead. See what it is? Rock with lots of chemicals on the head. It's real time, so I've gone out and seen it before as well. Picture of myself, tools, GPS, watch, magnet, water, go, see what it is. Come around, if we see anything else. Can actually see it coming into the center of the screen now. Heart's racing. It's a good old tin can. And believe me, there's a lot of them in very remote desert areas. So just bear with me, we'll just get this restarted and then So touched on the gear there a little bit. So I'm typically out in the desert. I have a wrist GPS, a pick. I always carry a 5-litre bottle of water at the start of the day. I have a little backpack which has an extra medal, couple of litres in as well. But I tend to use 5 litres as just drinking water all day as I go around. Nibbles, snacks in there, the scarf which I have over my head. And the way that I tend to drive somewhere, and I walk between about 500 metres and 1 kilometre from the car, out and just walk around in a big circle and hopefully hit something. If I don't hit something, I just drive on another 10 kilometres, whatever I decide, and then eventually hit something. When you hit something, then you just zoom in and you just look closer, and that's pretty much it. I actually have a satellite phone as well, and that's 2 watches there. One of the watch on the metal band is actually an EPIRB, so if all worst comes to the worst, I could pull a button, and if there was a plane flying over, they would at least I would get rescued. You know, I've never had to use that, but it's just kind of peace of mind. in the end of the day, if you're in the desert, you burn a tyre on your car. Bedouins come from anywhere. That's top tip. You don't need any of this stuff. Just burn a tyre. Smoke goes up, and people will come from miles, and you'll be saved. Won't be a problem. But if you're bitten by a snake, it's a different matter. Then you've got to look after your vehicle. Now, you won't be able to, it's a difficult one to see, but this was taken, and unfortunately this time was on UK time, so it's a few hours out. But I was just racing down into this sort of salt pan, just took a little fun selfie, as you do. Looked a nice place. Raced down and realised it was a really dangerous place to drive, because you're driving and it's an old salt seabed, and if you drive along these places you can actually drop below your axles in there. You just can't get out. There's no way, because you'd be stuck. So I realised that, turned around, and then raced at full pelt to come up, and it's actually quite a steep ridge. And when I came up, this wheel burst out on me, and thought, fine, change the wheel. Always carry at least 2 spare wheels. As I was changing it, if you were to see closely on this, you can't see it on the projector, unfortunately. First wheel stud I took off, it snapped. Oh. The next wheel stud I undid, it snapped. Oh. It was a bit of a Panama moment then. I think I had got my tuna fish out and got the oil, put it on there, and had my supper and really thought about it, And then eventually had the bottle to do the third one, and it came off. And so fortunately I had three studs, which were good, But you're in the middle of nowhere. And I have had a friend, not meteorite hunting, but work related. He actually went down drove back on 2 studs. Can you believe it? I mean, you're driving about 5 kilometers an hour, something like that. But these kind of things you just don't think of. So if I was you, hire a car, actually take the wheels off, make sure they actually work, if you're really going to do it properly. Then driving back after that, next morning, had a blowout on the back tyre. There, that was literally the next morning, blowout there. And then a week, another one. So you're coming across these kind of things. So you've got to make sure you're equipped. The last time I went out, I had 3 spare wheels in the car. So just never know. So this was a proud day on my first trip. Now, as I said before, I went equipped with this car. Didn't have as much food as I just really had, kind of noodles and stuff like that. I now go really, really good food and all the kind of stuff which I know how to locally source. Eat during the day all the time, nuts, sort of energy bar biscuits, fig roll bars, loads of water during the day, noodles, sort of tuna fish, beans and chili, all that kind of stuff, and chocolate bars and juices, little cartons of juices all the day, as well as your 5 litres. So I was driving around everywhere, driving at night, looking during the day, hardly getting any sleep. 11 days went past and I didn't find an absolute bean. I was just like, what is going on here, And I told people like Dave Gavin, I told Jamie, yeah, I'm going to find meteorite, I'm going to be out there. And they're going to think, who is this guy? Yeah, he was just sunning himself on the beach, the Arabian Peninsula. Yeah, he's been out there. And then I was pretty down, desperate, went off this sort of track, camped, woke up in the morning and do your ablutions as you do in the desert. I had a cup of tea and I saw this little bird. This little bird was just in the distance. It's just this little, I just thought I'd walk over and see it, and the bird just flew over this way, And as I walked over that way, I found this rock, the magnet on the stick, click. And I thought, no, it can't be, can it, And this was it. This was number the first meteorite I ever found. So you can pass that round. That's the first one. That's M1. And so you just feel free to pass that round. And then you think, is it a meteorite? Because you think, no, I must be joking, Then I walked on and I found some other little fragment bits, and then they got, and I found my own little stream field, These are actually from different stream fields, but found my own stream field. And so this was 2 days after that, and you can see a few meteorites on there. I have better kit, better chairs, better all the kind of stuff, that really lightweight stuff now. And so that was it. But and it was very interesting. It was in the place you wouldn't normally associate with finding meteorites, and that's the big tip if you're looking for meteorites. anywhere from deserts to Antarctica, wherever. Look in the places where you don't think are obvious. You know, that photo I had earlier, which was on those sort of cliff, those no one's looked there. Oh no, you want that dead flat area, that's where you want to go. You look along this dead flat area, how many people have looked at, how many ancient people have seen a big black rock? Well, that's interesting, I'll put that in my pocket 2,000 years ago. It's going to be useful as a loom weight or something like this, you know. And you might be lucky if you're in the middle of nowhere and you're the first ones there. But it is quite interesting. Look for those little rough and ready areas, you know, the sort of hidden ways, and that's where the good stuff has come out in the past. So we'll play this little video now. So this is what it is like finding, and this is the first one that I videoed finding.
Hi, Paddy. I'm out here in the desert watching for rocks. So I'll just pan over and show you the old car.
You see the car way over there.
Oh yeah. Pan out. Walking along. This is what it's like. Some black stuff everywhere. Walking. It's a scrubland, there's a bush, and then you walk along. Footsteps, I've actually just walked a little bit up, but I've just come back to take a picture. This is what it's like. Walk up and there's a noticeable object here. And here we come. That's what it's like. Finding one of these rare rocks. There we have it. Close up, view of scale, my hand, watch. It's actually quite a fair size. Okay, so this is number 2 of the trip. B002 on the 20th of February 2007.
And that was quite a few trips into, it was 2000 was my first trip. There's quite a few trips until I actually caught a video of doing it.
That was quite a big one, though. There was no doubt in your mind.
Absolutely no. And that was a couple of days before I found the meteorite on that trip. So that was number 2. So this is what I do. That's the meteorite there. This is the kind of location photo and science I do. Have a GPS, either the wrist GPS, but I actually use the hand GPS, which I bring out, which is better to use. Record it. I have my little notebook which I write all the information, time and everything, and then I line up a compass for position, location north. And you might notice I have 2 compasses there. I had a problem. Trip before, I had 1 compass. The compass, I could not believe you have this one. You think you're going mad. You're in the middle of the desert, middle of nowhere, and a compass starts reading south. What is going on? You know, and I actually take 2 compasses now. This compass just went completely right. It didn't just go off a little bit. It went completely south, north and south. I've never seen anything like that before, and very, very bizarre. So that's why on that trip I had 2 compasses, and have a scale. And on later, I have a scale cube there as well, which I didn't have on that trip. And then then I have a horizon photo as well, which gives you an idea of what the outlying is. So this one again is not here, but this gives you an idea of what they're like. It looks much bigger than it is. It's about this size, you know. But again, that was actually quite lucky. It's a very, very dark rock there. It's not as easy as you think. There's a lot of, you see this little rock here. There's lots of rocks that are like that. So it was good. It was good to find that one. And I won't play this video because I'm just thinking of the time. We've got quite a few bit to go. But there's actually we will. So it's just an evening discussion. So this is what it's like in my little camp. And that's that meteorite which you just saw.
The Thursday the the 13th of March, evening time, at camp here. Just finished my walk around at this location, and this is what it's all about. Here is that one that you saw earlier in found, and this one now, I'll just unwrap it, carefully wrapped in tissue paper, is D001 unraveled.
And that was the first find of that particular trip.
Hold it, keep it up my hands. I will just give you a view of it with a little bit of tissue paper still holding it. It's probably about a kilogram and a half in weight.
It's actually about 2.5 kilograms.
Beautiful specimen, very blocky. This is what it's all about. Now time for a well-deserved cup of tea in the absolute middle of nowhere. You can see I've got some firewood down below.
You can't,
Little bits of wood which I picked up, probably very old seismic lines which have since blown away. They double as some firewood. Got my trusty geological hammer as well. And I should move it. Just give you a close-up view of this. This is it here. Beautiful rock. Now I should wrap it up. Now it's time to take off my scarf. Okay? Well, it's good night, and we'll see what the lakes are tomorrow.
And then you've got ones like this. You can actually see this one here. This is the scale cube. I have a centimetre scale cube which I used from there. Used that, which is very good. And this is a lovely orientation. This one here is on display. You can have a look at that one. And again, you can see the beautiful orientation of that, and pieces have come off from there. And that's...
The bits that came off will arrived somewhere nearby.
Absolutely. Yeah. Difficult to find, but they are out there. I have found a couple which do fit together, so do find pieces. There's a bit of a selfie there on a tripod, gives you an idea of the size. Again, you see the 2 GPSs there. I normally now use 2 GPSs just as a backup. Now this is one. That's actually on a slope. This is one that was buried, and this is this one here. And that is amazing orientation, actually. When you have a look at that, you see amazing flow lines on that. That really is a special... These two are the most special meteorites for their orientation. And this was hidden away. So imagine how many meteorites are under the ground. And this is when it's dug out. And it gives you a shape. But you can see the real shield of it. You can see the massive flow lines of it coming out. And that's all complete. Again, you can have a look at that afterwards. And that's me there, just the usual selfie. And then we go on to this video. So now this L21, I actually had the handheld GPS, and I had it. I looked and I thought, right, you can actually move a cursor around on this, and you can actually choose a point and then just go to it. So I chose a point that was about 19 kilometers away, and just went go to on it, and it took me about 2 hours because because of the terrain, it's difficult to get there, and every 2 kilometers I was stopping, doing my little walk around, finding nothing, you know. And then, unbelievably, I saw this black object, and my GPS beeped, and a message comes up: approaching destination, which means you're about 40 meters away from it, and this is the video of it. And I start to wonder: are they trying to find me now? You know?
11th of February 2012, 1:55 in the afternoon. Just standing around, showing you the beautiful scenery here. Might zoom into a few little bits.
You can see the lack of the tyre tracks there as well. You really are remote. Tyre tracks.
Pretty remote here in the desert. We come. Gear. calculate it with the GPS, see if I could find a better specimen from the field which I first found, very first ones. So calculated a waypoint, put it in, and within 40 meters of that calculated point, come across L021.
And that's here. That's this one here.
Beautiful, fresh, crisp specimen. Haven't touched it yet. Just pan in there. All the way around. Very nice specimen. Give you the idea of the size, I'll just go and get my scale cube. So it's me, Will, here, just talking. As I get this scale cube, get my little trusty scale cube. Put it in place, just 1 centimeter. Put it 1 centimeter there. And normally I line it up to north. So we go north that way. So we go north there. So this is the way the photographs will go. Anyway, now around 2 o'clock, and another successful day in the desert. Bye for now.
We'll be in the office.
Absolutely. And then quickly, I'm going to speed up now. I know the time, so get it done quickly. There's another video. Now this is, you can see the difference on my face. This is looking for another couple of hours similar, and it's, you know, it's not just a case of just finding one straight away. So escape that. Yeah, 5. Quickly play this one.
After walking around the desert,
It's a bit hot after we walked.
hour and a half after my last find, L021. Just returned to the car. Been walking. I walk around a kilometre radius from the car.
It was a hot day
As
there.
you can see, water's run out. But anyway, I'll just pan around, show the beautiful view.
You could just see the car was just over there.
See the car over there, just zoom in. And then find L022. Similar size to the last one.
And that's this one here.
Again, a very nice specimen. See the time? Right before. Again, similar size specimen to the last one. Very nice. So, get a horizon view now. Nice horizon view for his light. So now GPS, scale cube, and photograph. Another one captured for captivity. Another alien caught resting in the desert. February 2012, what are we doing? Oh, I think I can take that off now. It's getting pretty hot.
And that's me there, just taking one. Now this is interesting. This is a statistical find. I was working in the desert, and every day I could, I just walked and looked. I was working night shifts, so I could get an hour every other day, working about 12 to 14 hours, but I'd try and get away for a bit. And I had like a breadcrumb trail on my GPS, so I could just go off and I'd know exactly where I went. It took me 60 kilometers. That's just a stone tool, but this is the kind of things you find in the desert. Interesting things as well, you know. Fossils as well, beautiful fossils, you know. Kind of gives you, camels, all kinds of stuff out there, gives you the train. And find this one here. And that's, so 60 kilometers, statistic walking, maybe you find a meteorite in the desert, you know. So, but just looking all the time, you know. And it's a very nice, again, this one's here. And so that's what it took, just statistics. And that's typical layout of the photos. It's me there, looking happy, because I was very pleased to find that one. Took a long time. Now this is, you remember the photo on the right, the bad place for looking. This is a modern meteorite hunt. I went with another meteorite hunter. There's a guy called Rob Elliott, runs Fernley Meteorites, and there was a meteorite that came down in Norway, and we went looking there. And so I'll keep it very, very brief. But we went out there, and then we heard that there was a big fireball, and then a guy was there was a radio ham in his little tin shed, and he remembered when he heard this, after this explosion, he heard a little tinkle on his roof, you know, and that was the first meteorite he found. He found a little fragment of a meteorite, and then it unfolded. A couple of days later, it was summer somewhere in Norway, and the family came back, and they had their cherry tree pride of place in their garden, and they went out to mow the lawn, and the big branch was broken off the cherry tree. What the hell, when a big meteorite hit that, the branch had come down, you know. And then this got all the speculation going, you know. And then, so we're trying to triangulate things, and people from all over the world. There's a guy here, your very famous meteorite guy with the big hair on the left in the sandals. It's almost like the question of, who is this person, the meteorites, you know. But this is on top of an industrial building. And it started raining a few days after we were there, and this big industrial building started leaking. Builder was called. The builder came up and found this hole, paces it up straight away, and then thought, hang on a second, why is this hole? Meteorite in there to come in, you know. And when you dig down, this is the kind of question of who is this person behind there, the meteorites, you know. It's like the hidden guest. The insulation, it was like the perfect bed in Norway for a meteorite to land, because they have heavy, you can see it's got the roofing felt, it's then got the insulation, it's got polystyrene, and it goes down into wood. And then you've got it's myself, Rob Elliott, and that's Robert Haag. Now Robert Haag is the meteorite man, yeah? He was there, and he's a great character. And that's us with that meteorite. We didn't find it, unfortunately, but that's, shows you can find them. But fantastic stories with Rob Haag, is out there looking, and the stories he came out was incredible.
Chondrite, that one?
It was, I forget what it was, but it was a chondritic one, but it was quite rare to find in Norway, and so pretty good. So now we have some photos. These are just general photos of some in my cabinet. The cabinet is actually still up in the Highlands. The meteorite's down there. It was a long story, but the cabinet will be coming down and it will get back set up. That's why I've got these in these boxes, which I can bring around. But I'm just going to flip through some pictures of meteorites, showing the different states of weathering that you find in pieces and all kinds of stuff. And again, that's that one. It gives you a better view of the shocking and stuff like that that's on there. Also, basically that will be calcite and stuff. That'll be terrestrial mineralization, which has gone in these cracks, and then they start to break it up. And then you've got bigger ones, different ones, and you've got different shapes. And you've got a whole pile of them. Those are scattered around. That's literally, it's like a wreck of a dead animal that's just been spread around, And over time, the rocks they move apart. Mm-hmm. And then you've got much cleaner ones, much more oriented ones, like that one there. And then you've got the M65, which you can see here. And you can see the lip of ablation on there. You can see where the molten rock has gone over. You can still see the flow lines on this. And you've got a similar thing on that one, 37 is like a shield again. It's got an ablated lip on. And you can see different types that are there. And this one shows very heavy chondral structure in there, again, which is very definitive. So that was, again, some different ones. It gives you an idea of the time. You know, this is over many years, many trips. And the biggest one there, to give you an idea, that's about 9 kilograms in weight. So it's, and then we can, looking up, let's top that.
That's amazing.
That's it there. And you might recognise those people, a few of the Dundee elders there, and one Edinburgh guy. Yeah, that's, you can see that's just maybe 6 months ago that photo was taken. So, and this is at the BAA. That's my friend Gus, who's in Edinburgh Astronomical Society. He's very keen meteorite. He's the one who goes to this festival in Chisholm every year. There's a few of the lads there, and Jamie, Ron, Dave, and myself. Let's go off a few things on the display. Just flip through, and as an ode to Thunderstones, play the final video. Now this video was taken by me out in the Middle East, and it's quite an interest of lightning. So that's the Dubai skyline now. Tallest building in the world, tallest lightning conductor in the world. These are the slow things here. So that's the biggest thunderstone there is. This is it real time. You can see the cars coming along.
Yeah, almost. Yeah. Whoa, that's awesome.
Again, this is real time. You see the cars and everything. You can hear my voice. And this is me talking real time as I'm watching.
1:15, Tuesday morning, 11th of January. Seen some lightning over Dubai to the Burj Al Khalifa, formerly known as Burj Dubai, tallest building in the world, 828 meters high, biggest man-made lightning conductor.
Whoa.
Yes.
Daytime shot. And I took this, you can see the plasma ball's been ejected from the top and it's hit. Yeah, I was lucky to catch that one.
Oh, yeah. Good job you went up the top of the top.
That's right. So if you're ever in Dubai, it's lightning strike, you know where to look. that's it. So that's it. So if we can have the lights on now, and then and any questions? Are we doing all right for time? Are we doing okay? Yeah.
You could
So
have answered the question to the extent that I was going to ask you, how long do you take to find one? But 60 kilometres, whoa.
yeah, that was statistics. That was in an area where I'm just looking, and there's reefs, old ancient reefs around and stuff, and that's what it looked. You know, that was I literally there because I couldn't walk away from where I was working, which was on an oil rig in the middle of the desert. I could only walk maybe 4 kilometres away, and obviously I was on call as well, and you have to be there. So I basically walked like spokes from a wheel. So I just walked out like spokes on the wheel like this, around, and then had a breadcrumb track, and then went round and looked and zigzagged and everything, and just took a different place. And,
As good as any, isn't it?
yeah, absolutely. And it turned up trumps, you know. So it shows they're out there if you look, as long as you're looking.
Point in us going up to Cooper Angus and looking around the fields there.
Well, to be honest, I reckon if you, I mean, very little chance, but you never know. But they are there. You know, the problem is in Scotland there's a lot of masking, a lot of meteorrongs which hide them away. You know, so it's and the weather will degrade. They will sink in the soil and all kinds of stuff. You know, so yes, go ahead.
Just a curiosity really. Have you ever revisited a site where you've not found something and found something the second visit or the third visit at all? No, because I haven't. If I haven't found something, I won't go back there. So, and to give you an idea of the stability, I mentioned briefly, if you know tyre tracks in some of these remote desert places, they will be there for about 60 years. So that gives you an idea of the sort of interesting natural environment that there is there, so that's another reason why I don't just drive. You know, I could be driving like this, zigzagging all over the place, but you ruin the place. I like to walk. You're part of the nature. You know, it's so quiet in these times. You hear the flapping of birds' wings, you know, above you and stuff like that. As a bird of prey looking, is he going to drop down dead and I can eat his eyes? You know, something like that. You know, but you actually hear. You hear the flapping way up high, you know, of that on a cool day. And I've revisited a place, for example, I've gone back to a place 2 years later, and I thought, well, I must have missed something right here. And I always clean, if I have a little fire, I always clean all the rubbish out, but I'd left a tiny little piece of charcoal, and the fire pit was still there, and there's a little piece of charcoal, a little piece of wood was still there 2 years later, you know, so that kind of says it there. So.
Interesting question that Tony asked. I was assuming that where you're looking, you'd have winds that would cover them up or uncover them.
Absolutely, but I tend to go to bedrock areas. I tend to look where there's bedrock. That's why it can be very difficult driving, and that's why I'm susceptible to getting punctures and stuff like that. I'm not keeping on that sandy soil, and I keep away from dune areas. So I'm looking for these areas that have been uncovered. There's not so much shifting. But they're just away from, you know, geologically more stable, I suppose. Yeah.
Is that because it's a harder surface then, and the rock won't embed itself in the surface? If it was sand, it would make sink. Yeah.
It would. You actually find it's a funny old thing. Over time, you tend to find that actually larger things come to the surface because you've got small grains of sand that would filter down, you know, so it's a natural selection. But the meteorites that I'm generally finding, I think some of them actually may be a lot fresher than you think. We think a few of them anyway, but a lot of them are historical. They've been maybe hundreds or thousands of years old, and they've been there dormant, but so that they've just been resting there, you know, and you can see some of the weathering of them. They're just broken down into pieces. They've just been, you know, all gone. But you don't tend to. That one which was buried, this one here, like an iceberg, that was on a slope which was actually quite steep, and it had gone in. But that, whether that was it landed and it was like that, or whether that was erosion of the cliff, you know, the sort of reef that had covered it up afterwards is difficult. Whereas a meteorite lands in Scotland in a field, it's just going to embed itself in the ground, especially if it's a peat bog. So, yeah.
You mentioned at the start that you're finding or you're identifying them by whether they have iron in them and showing up with a magnet.
Yeah.
But I thought one of the points about these things is that you shouldn't go near them with a magnet because you destroy any residual magnetism there, which apparently has scientific importance. And I was then going to say, can they use that sort of thing, and I don't know whether you've ever had it done, to identify, first of all, how long the meteorite might have been on Earth and how old it is originally.
Yeah, I mean, you tend to, I mean, the age of the chondritic ones is about your 4.6 billion years when the solar system formed. Then you've got the achondrite ones. Now, I don't have it here. I have one very special, which I'm hoping is something really good, actually, which, again, I thought was a meteor. Dug it out, and it was on my mind for 2 years. I'm not joking. And then I finally found it up in the Highlands in a box, hidden away, because I just thought this rock is special, you know. And I need to get this one particularly analysed. But this one I think, is planetary. So it's something very special there.
So you could have some
Martian, or I hope so. Or yeah, well, just something which could be quite interesting, you know. So it's. But going back to the iron, with a magnet, I don't think, you know, there's magnetism in there, but I don't think so. But there may be some very delicate science that they're doing with magnetism, which I'm not aware of. So it's.
I wouldn't have thought there was magnetism with the heat coming in through the.
Yeah, I mean, there's just the iron content of them, you know. So.
I thought that any magnetism was probably due to sitting in the Earth's magnetic.
Yeah. There's no magnetism in. I suppose what you may have been insinuating was just the effect of the magnet having on the iron properties or something like that.
Yeah.
But it's.
I mean, that in fact is the thing, is being able to date it by the origin, or at least having some idea of its age, how long it had been on Earth, from the orientation of the magnetic field before you move it.
Not really magnetic field. They look at the there's ways that they can they can get the terrestrial age by analysing how much weathering it's undergone and how much decay of the rock it's gone due to the atmosphere of the Earth. So, and that's how they can give an idea of its terrestrial age. So, yep. Sorry. Yeah.
Thank you.
Because you're using the magnet for particular traits, does that mean you get a higher percentage of metallic as opposed to stone? Yeah,
well, I've now got the state where I see something like this, I know it's a meteorite, you know, I don't even need to use a magnet, but it's just another tool. And the magnet I have is one on a long stick, so it's kind of like a walking, I don't walk on it, but it's kind of one of those things you just have, and gets pretty boring in the desert, you know, so you just get poking everything, you know. And, I mean, I was telling June and the lads earlier, you know, there was one case where there was, you know, you wouldn't believe how a piece of camel dung looks like a meteorite, looks like one of these chondrites, you know? And I'm not joking, and I was saying there was a trail of camel dung, and I was so bored, and I went poking, and it's just soft, it's hard, it's just like a piece of compressed cardboard. You knock it, and it's just like a, you know, like a toy ball or something, you know, when those little soft golf balls that you just practice with, you know, you just knock that and it makes the same noise and all that kind of stuff. And then I went dong, and it stuck to a magnet, and they were right in the middle of this pile of camel droppings. There was a meteorite that looked exactly like a camel dropping. You just never know, you know. So it does show always to check. So it's yeah, that's right. And it is, you know, and you have, you know.
Got a fright man.
That's right. Well, maybe it swallowed it, you know. Maybe you know, maybe it was sleeping with its head out like that, and one dropped in and you know, got it out. So that's right. So yeah.
Well, that was absolutely fantastic. If we stop just now, at least we'll get a chance.
Of course, absolutely, yeah. No, I wouldn't have touched them, but you can put a glove on and hold carefully, yeah.
Well, I can't tell you how desperately I now want to find my own meteorite. I can just see there's a few issues in looking for them.
No, that's right.
Go on.
Expedition for DAS.
DAS. That's next time we're sorted.
June, there's a nice project for you for the society. You just talked yourself into that one.
Oh, God love us. Our first snake, and that's the end of it for me. Oh, jeez. So, Will, thank you ever so
That's
much.
right.
That is
Pleasure.
absolutely
Pleasure.
fascinating. Thank
And,
you.
no, that's all right.